Hi everyone. I'm sure a few of you we saw this morning in the keynote, but if you've just joined us, welcome to Civo Navigate. And today we're going to talk about sovereignty. Obviously, the theme of this event is AI and sovereignty. I'm sure we're going to cover a bit of AI. Always seems to creep in there. And certainly from the keynote today, there was a lot of talk about sovereignty and what Civo's doing. And we talked a lot about cloud parity and the fact that we believe you should have public cloud options, but also that ability to take the same thing privately. And just thinking about that future and playing that forward a bit, Kelsey put a slide up there where, we're imagining this place where, Civo has, say, 10 or 15 regions now, but in the future there could be regions everywhere. We might not own those regions, but it kind of democratizes sovereignty and control into the hands of the users. And so that's a good place to sort of start from. What do you think that world looks like in the future, say, in 5 years' time?
Yeah, so there's no secret. I used to work at a cloud provider, had plenty of proprietary services. A lot of those things did change the way we think about computing in general. But I joined Google after Kubernetes is released. And so look, you go to, as someone who has a big open source background, I contributed to Python, a lot of open source tools like Terraform, Puppet, my own tools, and I spent a bunch of time at CoreOS. And so for the majority of my career, I've been trying to build open technologies, mainly because that's the only way that I got into the industry. I didn't go to college. I never used the big Unix enterprise systems. My only access was because of the democratization of things like Unix via Linux, having access to the information and the knowledge because of the internet. So of course I gravitated to this thing called open source. So my whole career, we've always been challenging the incumbents by building these systems. So I get to cloud. And remember, I'm getting to cloud where Google believes the only way to compete in a world dominated by AWS, untouchable at the time. Then you have companies like Microsoft Azure, and it's like, what does Google do to stand out from the crowd? And open source was one of the big linchpins. We saw it work in the Android space, we saw it work in Google Chrome, we saw it work with the Go programming language, we saw it work with TensorFlow, and so that was just a common pattern that we were able to execute on. And then something magical happens. Kubernetes comes out, and we got a lot of people to adopt like the Red Hats of the world and the practitioners of the world. And then Microsoft announces they're going to support Kubernetes as a first-class thing. And not only that, they're going to stop trying to support all the other things like Docker Swarm and Mesos. So they kind of pick a winner here. And Amazon does the right thing, they wait. We're not touching this thing until the IP is spoken for, there's a foundation. This thing needs to be like Linux. It needs to be an even playing field that no one vendor can take their ball and run away or prevent us from innovating on top. This is super important. And even when that happens, they wait some more. They wait until their customers ask. And for me, that's the best validation in the world that something's going to actually take off. It needs to actually work in production and add real value. And so if you're at Amazon, you watch 3 or 4 KubeCons go by, and they're just getting bigger and bigger. And your customer says, hey, that Kubernetes thing looks amazing. When are you going to get it? And eventually they offer something. And once you get that validation and the Oracles of the world follow suit, the SAPs of the world follow suit, I think SUSE is represented here, they follow suit. Everyone seems to have a Kubernetes offering. Oracle even supports Kubernetes. You're like, okay, maybe this is where the industry is now headed. And so when we think about sovereignty around this original question, the thing that has to happen first is we need to have the best of the cloud be available everywhere. And a lot of the customers of cloud push this narrative themselves. Hey, we're still using mainframe because we're still getting value from the mainframe. What you've promised wasn't better, so we're sticking with it. And this is true, I even learned COBOL in 2008 because someone taught me Pacdecimal and Epsidict, and it was actually faster than the things we were trying to do in Java, so I understood. And so I think a lot of companies took a little time to realize this, so they kept with their mainframes. So it turns out everything didn't move to the cloud. There's this narrative that everything went to the cloud, and now people are moving some of it back. If you're a real practitioner, you know that everything didn't move to the cloud. Some things stayed where they were. And just your luck, Now that a lot of the cloud providers have agreed, especially on the common parts, networking, storage, some of the compute layers are now all backed by open protocols. Even Datadog supports open telemetry for metrics processing. Every system now has an S3 protocol, even on top of proprietary systems. So I'm a big believer that even if the implementation isn't open source, if it uses an open protocol, that will do. So that's where we were. It took about 15 years to get to this point. And so when I met Mark and team, and they're, oh, we got to close the gap. We got all these things to do. How do we? I was like, you have the late mover advantage. And one of the best companies in the world has demonstrated the value of the late mover advantage is Apple. One of the richest companies in the world always gets criticized for being one step behind everyone. But they usually wait till things mature, have a secure supply chain, that they can actually move the number of units they want, and they use the technology to its perfection. So now that we're in this world where we can have all these technologies and you no longer have to make the trade-off. 10 years ago, the only way to get access to these tools was to move your stuff to where they were. Now, even the cloud providers want to move the compute to where the data is. Data gravity is still a real thing. And I think the way we want to compete is now that we're all working on this common set of things, we all have agreed, including the proprietary vendors, it is now finally possible. And so that's how I think it plays out. And if the industry does what it's typically capable of doing, we will decide what the future looks like. So the quote I like the most is, it's easy to predict the future when you're working on it. And so if we decide that we want to continue to use open protocols, and the last thing I'll say here too, because I think it's super important, everyone thinks all this innovation comes from the vendors. I remember the first time I was working in financial services, there was a company called JP Morgan Chase, big financial institution, been around for a very long time, probably have all the legacy concerns that every other big bank has. They open sourced this messaging protocol called AMPQ. There's a binary called Cupid. And I used to manage mainframe systems, and we used to connect them to a thing called IBM MQ series. This is how the banks usually pass messages to each other. It's super expensive. It ain't cheap. I remember trying to automate it once, and they were like, hey, every time you spin up an instance, it's $2 trillion. It's like, wow, damn, it's pretty expensive for a dev environment. And this bank delivers this open source project, donates it to Red Hat, then it becomes AMPQ, which is the standard for RabbitMQ. And so there's this bank innovating in the messaging space. And that goes on to create all these other side effects for open source projects. Argo CD comes from the people that help you do your taxes. Intuit cultivates this project that has dominated the way people think about CI/CD in the infrastructure space. So we can go on and on of all of these new technologies that are being born from the very companies that are represented in this audience today. So I got a feeling that we're going to be able to run cloud native stuff wherever we want because we are now the builders. It's no longer the vendors in full control.
Just thinking about the the adoption cycle, we were talking about NVIDIA in terms of they've backed Kubernetes and open source. Do you think AI is the thing that's going to drive a lot more sovereignty? Because maybe some of those, you used the word, we used legacy this morning, maybe we don't use legacy, we use money-making systems. But that new, modern AI workloads that maybe don't come with some of that baggage, new workloads, new use cases, is going to drive a lot more adoption into moving things, like you said, where the data moving towards the data rather than the data moving towards the cloud.
The thing about the AI workload, it punishes you for bad habits. Like if you got a bunch of little Java apps running inefficiently, whatever, it's going to cost you 4, 8, 16 gigs of RAM. Right? You leave things on when you should really turn them off. You're going to negotiate a 30 to 40% discount with your cloud providers, give them 5-year payment up front, and you can kind of hide a lot of your inefficiencies as a company. We've been doing it for a very long time. And on-prem, you can hide a little bit more because you can amortize that cost over time, and you pay the ping pipe and power that sits underneath. So we got a way big time with the traditional stuff. But when you think about an AI workload, meaning the most inefficient workload known to man, it's actually very inefficient, so we need specialized hardware to make up the difference between what we're trying to do and what it's capable of doing. It's so inefficient, you damn near need 800 gigabit links between each of the boxes of GPUs just to keep the thing moving. And if you want to train one of the larger models, we're talking months. And I've seen people like, all right, we're on month number 2, and one of the things like goes down. And think about having to start over. Like I've restarted our sync job, right? You move like 2 gigs out of 3, it's like, I just gotta restart it, and it finishes. 2 months, right? And so this workload is very taxing. So imagine running a 2-month job in the cloud, and it fails. There's no refund. They're not, oh, your job failed? Oh, we'll give you back 80%. And if you looked at the cost, if any of you have ever tried to run like with the most modern GPUs, first of all, if you're too small, what do they tell you? You're not, you can get 3. Well, I want 100. It's like, you're not getting 100. You can get 3. Call your sales rep. And your sales rep says, hey, what's your yearly spend? We're about 80,000 a month. And then the dial tone, like they hung up on you. It's like, you're too small, you're not getting the GPUs because we don't have the GPUs. And so I think the AI workload punishes bad behavior. So if you don't have a good architecture, you have no automation, and you're paying a premium to use rented GPUs. Remember, GPUs came out, everyone was thinking they're gonna get per minute billing. They don't do that in most providers. What do they do? Oh, you want a GPU? You gotta commit to some of them to the day, 2 weeks at a time. These things aren't cheap. So I think a lot of people thought about it for a moment and said, well, if we don't have the right operational model, then we got to go back on-prem. I can't pay this premium for something sitting idle in a cloud provider. It's too expensive. It's more cost than all of my other IT spend on compute combined. So I put it back in my other data center, and I don't pay the penalties for my own inefficiencies. Also, the amount of data required to get any value out of these things is astronomical. Most people want to put all their data through some of these systems. And remember the thing we said earlier, all that data didn't move. So if it didn't move, where is it? What did we learn about distributed systems 101 or computing 101? You move the compute near the data is usually the fastest thing you can do. So I do think this trend will continue, and the cost, I think. So I think you're right in terms of like access to hardware and all these other things, but I think the cost is so prohibitive doing it the other way, you almost have no choice but to try to run this thing in the cheapest place you can to have that 24/7 access.
Do you think we went too far in terms of we rushed to the cloud, we put everything in the cloud, and now we're having that, realization that actually it's not a one-size-fits-all, and AI is the wake-up call of different workloads, big data, that's now driving a slightly different thought process?
I did this exec briefing. So at Google, I became an executive when I got to the principal or distinguished engineer status. Like, Kelsey, you now need to be an exec sponsor, right? These companies need help at the executive level. And so when you're dealing with developers, Hello World works well. When you're dealing with the executive team, we're talking about CEOs of these Fortune 2000s, it's Hello Revenue. They don't really care about Kubernetes versus this other thing. There needs to be something to captivate their attention. And I remember, our PMs come in and they do a fantastic job showing our products and our services. And I thought to myself, I was like, imagine an executive that's doing the roadshow. You go visit Google, you go visit Amazon, you go visit everyone, and they pitch the best of the things that they provide. They all do the same exact pitch. And I remember, they're like, Kelsey, where's your slides? I won't be needing slides for this one. And all the PMs stick around because they can leave after their presentation, like, what the hell is he gonna do? And I would walk in and I would say things like, the thing you need isn't for sale. Oh, well, what kind of statement is that? Like, we came here with checkbook in hand. I was like, the thing that you need is the discipline part. 15 years ago, you could have had fully automated deployments using Jenkins. 15 years ago. You could have had close to reproducible software using RPMs. 15 years ago. Take your software, build it, put it in an RPM, put it in a Yum repository, sign it with a GPG key, Yum install, make sure that the key is there. You could have did this 15 years ago, fully automated, all day long, easily. Docker takes that same pattern, same exact process, maybe a little slightly different packaging format and layers. So you never did it. For 15 years, you always had this option. You're like, I don't know. It's like Google was born in that time period. Facebook was born in this time period. All these companies were born without any of these technologies that you're seeking to buy today. So they were able to do it. Why were you not able to do it? And I think that lack of discipline of not understanding what a cloud operational model is, and like Kelsey, we don't know. It's like, no, this is what you did. The developer's like, I need a server to run a web app. You get to do this once every 5 to 10 years. You need 4 gigs of RAM. What do? We need 128 gigs of RAM for this server because I'm never getting another opportunity at this. So you fill out the spreadsheet or the ServiceNow ticket, whatever you're using, and you ask for the biggest thing you can possibly get your hands on because you will never get another shot. And I can't believe it today. Companies are still talking about taking months to get a VM. Think through this for a moment. You can go to the desert, get sand, figure out how to turn sand into silicon, invent Intel, create a computer from scratch in about 9 months. Or you can open a Jira ticket and wait for your IT team to do God knows what for 9 months to get a VM. How is it taking 9 months to get a VM? This was the standard operational model for a lot of IT companies for decades. And you give them the cloud. What do you expect them to do? The thing I learned in 7 years of the cloud was every customer eventually wanted us to make the new thing work the old way. Hey, I noticed that this thing starts really fast. That's a security concern. What if someone wants to do work and they can do it really fast? They may create bugs. I'm like, what? We bought this enterprise software package. It uses 2 trillion gigs of RAM, and it scans the file system for things that shouldn't be there. We want to install this on every node. All of them? Yes. And so cloud providers are like, okay, we will let you do the old way on the new thing. So if you look at most cloud providers, they have exactly the same services that you had on-prem. Oracle supported, SAP supported, VMware supported, Palo Alto Networks is supported. I thought you were trying to move away from it. They didn't. And so we didn't change the operational model. Most companies didn't even change the way they were doing things, and they did it all at a premium. And then you add the fact that you didn't even move everything. So now you have 2 things to manage under the same operational model. That was the mistake. It wasn't the speed part, because if you did it fast, at least you would have learned it was a bad idea quickly, and then you could have went back. But no one finished it. Most people have never finished their cloud migrations. Most companies have never finished. They started it. You ever heard that? What do they call it? The Center of Excellence. You ever heard of those? Center of Excellence? So if you've never heard about a Center of Excellence, this is how they work. And you have a town hall, kind of feels like this. You're employed there, and you're like, hey, there's a town hall, and the CEO comes out and says, we're announcing the Center of Excellence around cloud computing. And you're like, And then they hire this new person that has never worked at the company. And they bring them in, and they come out, and they do this presentation like, hey, we're going to get us from point A to point B, even though I don't know where we are. And in about 18 months, we're going to be fully running in the cloud. Now, you're sitting in your seat, it was like, I don't think they're going to be able to move this mainframe because we've tried 30 times. And they give out this strategy, and you're sitting there, and you go home, and you're telling your wife, it's like, hey, they started this new Center of Excellence. And I realized I wasn't in it. And they've created this subgroup of people who didn't even understand the current infrastructure in an attempt to take everything and move it over there. And they've probably been fired 3 times. You ever look at LinkedIn? Ran the Center of Excellence for like 5 companies, 18 months each. And if you want to know how to interview this person, you don't look at them. You just got to turn to the whiteboard. Because when you look at people, they tend to lie easier for some reason. I don't know why, seriously. But when you look on the whiteboard and say, tell me exactly how you finished your last cloud migration, and just start drawing what they say. And it turns out most of them have never finished. They do about 10% of the stuff that no one uses, writes a press release, and get fired because they can't do the rest of the stuff. So I think it was more about the operational discipline. They never cleaned up their act, and they bought cloud anyway, and they were on the clock because you start paying as soon as you sign the check.
So what's the lesson learned? What do we do differently next time?
Everyone got smarter, though. Like I said, a lot of innovation, the cost management stuff comes from traditional companies. They built tooling to go on top of these cloud providers. You, the practitioners, you've learned the programming language. You built the integrations. You made Terraform better. You made Kubernetes better. You built the thing for certificate management. You took some of the things that were not understood by the people building these tools, and you added the features. And then you've moved around. A lot of you used to work at Google, you now work at the insurance company. Some of you used to work at Facebook, now you're leading AI at a traditional retailer. People move around. So after a decade of people moving around, a lot more companies have expertise now. They know what to do now. They have the battle scars. They have actual experience. Now we've learned a thing or two. And so now they say, hey, if I got to do it over from scratch, this is what I would like the world to look like. The challenge is, will the executives listen this time? That's the part. But the good news is a lot of them are out of money, and they're probably going to get fired. So it's just a matter of time before they rotate out. And then some of you become the executives, and then I think you will make different decisions, and hopefully better decisions, and hopefully the industry will be there to meet them if they choose to exercise those decisions wherever they want, including in their own data centers, if that makes the most sense.
So going back to what I started with at the beginning about where it might be in 5 years, and some of the things you've said, how does it look different? You know, in terms, we talk about sovereignty, we talk about cloud, private cloud, we've got different vendors involved. There's always this talk of multi-cloud that never seems to really materialize. VMware, Broadcom lock-in, all these sort of things, you know, that have happened. AI coming up. Where do you think we need to be in 5 years? Where will we get to? Or what needs to change? And so we can, no, I mentioned it this morning about the one size fits all. It's not a one size fits all. It's not just cloud.
Sovereignty isn't just run stuff in your own data center. Having the expertise to run stuff on your own data center is a big component. And then having the expertise to build things that don't exist is another component. There are a lot of countries right now that don't have those two things. So they're beholden to whoever agrees that they can have what they have. You can get slapped with a tariff, a sanction, and then you have to turn it off. That's detrimental to people. Technology was cool when it was just maybe an open source project you download for GitHub. I forget what country, I do know the country, but I don't want to say their name. They deem GitHub dangerous for children. So imagine them blocking GitHub. And you can't get to GitHub anymore because some policymaker doesn't understand what's going on. And so the thing you need to run your business is now no longer accessible. And so I think the only thing worse than like lock in is lock out. Because maybe it's expensive, but when you don't even have it at all, that's exponentially worse. So when I think about this is that the intelligence on how to do these things. So when we say sovereignty, you also get to the nation state side. It's a shame you go to some of these countries and they have no one in those home countries that can't do things that have been done for 20 years by other countries. This is insane. Like the thing about the EV revolution that I thought was amazing, I went to Portugal and I rented a car and there were so many car manufacturers to choose from. 10 years ago, Mercedes, BMW, Toyota, Ford, maybe, that's it. Now I go, India's making cars. The Chinese are making cars. People are making cars. They're cultivating local talent. You now have startups of 5 people making cars competitively. This is what, to me as a technologist, that you want. That is sovereignty. The ability to move the needle without permission is a form of sovereignty. So if you're a world leader, a local leader, a team lead on your team, the ability to create things is very empowering. When people ask, should everyone learn to code? We went through this before. If you're in IT and you don't know how to code, that means your whole job is in read-only mode. Your whole job is read-only. You can only do what the documentation says. You can only do what the best practices guide says. And whenever those things don't work, you're just stuck. That's it, you're done. If you know how to write code, you look at the error and you fix it. If you buy something from the vendor and there's a gap in feature set, you can add it. It changes everything once you have that level of sovereignty. So that's what I mean by sovereignty. The ability to see a feature that you want and the ability to make it happen without permission from someone else.
Okay, I think it'd be a good time to open to some questions. We'll make this more interactive as well. So on the subject, I guess, of sovereignty, but I'm sure AI is going to creep into it.
Any question is fair game. I love this part of the talk because I'm retired. I don't necessarily am tied to any particular outcome. That means I can be as honest as I've ever been before. So take advantage of it.
There's a mic coming, actually.
There we go. It's not going to make any horrible noises. What are your thoughts on the UK's efforts in AI research resources? So Bristol's just got one. There's one in Dawn. There's going to be one in Edinburgh. Yeah, just generally, it seems like it's...
Unlike AI, I won't sit here and pretend that I know the answer, so I will avoid hallucinating on this one. I think there's a common answer. Education tends to be good. If you want AI to go in a certain direction, then you have to step up and nudge it that way. This idea that you can kind of create laws or wish it would go in a certain way does not work. Does not work by itself. So yeah, any situation, but the nice thing too is it's beyond the universities now. I remember, I didn't go to college, but I was a contributor to Kubernetes and etcd. These things implement a lot of these distributed system principles and theories from the white papers. The nice thing about etcd, I remember when the white paper was published around the RAF protocol, better consensus algorithm. In less than 2 years, there was open source libraries. This is his PhD thesis. It's not necessarily adopted around the world yet. We read the paper, and there's a Go implementation in a shorter time. Then it finds its way into practice and into theory. And I remember the first open source project I built was on top of etcd. And I was fascinated then going back into history and learning about Leslie Lamport and all these ideas around distributed systems, how to do it well. And I remember Stanford University was like, can you come and do a guest lecture to our PhD students about applied distributed systems? And I thought about it, that the things that we're doing in industry at the various companies and the startups is all pushing this field forward. And I think the things that people are learning in practice about AI, applied AI, right? There's the theory of AI, but then there's the thing that you have to run in production. The thing that starts to hallucinate and causes problems with your actual customer base. The thing about reproducibility and the non-deterministic. The thing about RAG implementations and then how much data do you need, structured versus unstructured data. These are things that I think people are learning in production that is augmenting the research. So research is one thing, but the thing that I think is going to move it forward much faster is that loop of practice. And every company in the world that's trying this stuff out, they're part of the process now. So I think that is also as important. And the last thing I'll say here is all these companies that refuse to talk about what they're doing as if there's some secret sauce here, it's like, dude, you've downloaded the same open source model as all your peers. Stop pretending you're doing innovation. It's called downloading from the internet. It's not innovation, it's downloading. When you share your experience, what you get then is this collective set of knowledge across the whole region. Hey, we've tried a thing, we're banking, this is how far we've got with it, and we're stuck now. Then that gives someone else the ability to say, oh, we've gotten past that. Here's how we did it. And that collective thing just rises all boats. And in a country like the UK, that is super important to make sure that the knowledge infrastructure matches what we see on the technology side as well.
And just pivoting slightly on that question, we've seen a movement by OpenAI to open source their model, which is pretty much comparable to their ChatGPT 5. We see more open models coming out of China. We talked earlier about Linux, Kubernetes, open, NVIDIA backing Kubernetes is the platform of choice or the software of choice. Do you think it's become less important about countries building models, and really it's about openness and the best of what's out there? I guess what we really want is someone to actually publish the training data as well, so we can be truly open and know what it's been trained on.
Yeah, so we haven't got all the way to like open weights and all these things yet, but we're making progress. I think people are learning. But I remember when NVIDIA was just on a rocket ship, right? We have 85% margins. We just keep raising the price and you have no choice, right? OpenAI is like, it's not gonna be $20 for long. I remember getting Netflix for like $3.99. Now it's like $700. You know what I mean? It's like, this is not the final price, you know this, right? And so everyone was thinking that this stuff is on a rocket ship, and all the particular players have pricing power. They can just change the price whenever, and you have no choice but to pay it. You just bought this new AI stack, here's the new one. And then I remember sitting, and sometimes I watch those financial shows, and they're talking about all these stocks going up. And sometimes they have like the stock ticker just in the corner. And then it's like China open sources DeepSeek. You're like, yeah, what does that mean? They did it for like $800. Everyone, the stock just, it just went the other way. I was like, what the hell happened? Where'd it go? And then it's like that democratization is the thing that keeps things in check. You don't have pricing power now because they just put it on GitHub. And I remember it took like 15 minutes. People had tutorials. Startups were formed. We just raised our A round off of DeepSeek. It's like, dude, it's been out 15 minutes. And that's the type of thing that I think keeps the playing field even. So if you think about China's approach, they're like, hey, listen, we got to fund. Our country has to be competitive forever. So if I'm the UK government, I'm in the back of my mind thinking that we need to be able to produce a foundational model if the time came. So we should keep that research going. We should be able to do it. We should understand the techniques. We should be definitely able to fine-tune a model that we run locally for ourselves and never share the output of that because it's only for UK citizens. You should definitely be able to do that. So I think it's very important at this point because outsourcing your compute, outsourcing your open source libraries is one thing. Outsourcing your thinking, which a lot of people are hoping to do with some of these AI platforms, is dangerous. That is dangerous, right? This is why you're seeing the force of the sale of things like TikTok. Why? Because it's considered dangerous to have someone control the algorithm of a group of people who are on the phone for 5 or 6 hours. So this is why I think this stuff has become more of a sovereign issue, that I can't give away the whole farm to someone else. So I just do think it's important for that. So yeah, I think governments are already involved. It's not a choice anymore.
Let's take another question.
Hi there. I've got a interesting dilemma. Digital twins are now the next big thing within certainly the built environment for parallel simulation and scenario modeling. What's your kind of view on the implications of digital twins and also this ecosystem of cloud, AI, agentic AI, machine learning that actually underpins this simulation of digital twins for smart buildings, smart cities, and also smart avatars?
The buzzword soup is crazy. So when I think about fundamentals, right, one of the hard things about software is how do you make software like deterministic, that it's going to behave the same way, right? It works on my laptop, where your laptop ain't production, so things fall apart. So we haven't even achieved like digital twin for a thing. And there's always one little gap in these digital twin systems, which is sometimes the concept of time, right? Just introducing time makes things break, right? Like this binary works well right now, and then you copy it to the US, and because time has gone backwards, it interprets the data in the database wrong. Just time. Forget all the other stuff. So when I think about digital twin, I think it is a mode of efficiency. Right, fundamentally, we always thought about a dev environment. It's expensive to have production and dev look exactly the same, right? Because if you wanted to have the exact same Oracle install, you need the exact same drive, the size, the network link, the VLAN, and there's some errors that actually only occur when you rename the firewall rule, right? We don't even think about this kind of thing. Like, well, we have the same firewall rules in all the environments. But this firewall rule is named slightly differently. What does that have to do with anything? It's just a firewall rule name in a config file. Well, it turns out when you do Terraform apply, it's an invalid name. And that name doesn't get updated by Terraform. And you're ignoring the error. So while you're changing rules in production, it's skipping the one in dev. Now you have drift. These things are no longer the same. And these are the little gotchas when we say we want digital twins. Now, the case of the physical world, right? It's kind of the beauty of software. We get to take a thing that we want to work a certain way. And I think so when Kubernetes first came out, the thing that I was most excited about wasn't the scalability. It wasn't the distributed system nature. It was the type system that it gave to an unstructured infrastructure world. Like a CPU, a disk, a network, these are all unstructured components where the config lives in like 88 different systems. Kubernetes shows up and says, no, we're gonna give an object and a type to everything. You're going to submit that data, so it's infrastructure as data. And then when you have data and you have predictable behavior, so if I give you this data object, the firewall or the Wi-Fi router in the building, the temperature in this room, we know that this data changes this particular thing on the other side. So now that I have this type system, especially if my control loops always tend to do the right thing or reconcile to the right thing, it becomes way easier to simulate these environments. Now that I have this structure of configuration, then it's much easier to simulate a building by saying, we don't even need the building, right? I can take the configuration, and I know that the behavior changes given this data model, the state change will be this to this. So as long as the systems are now a little bit more deterministic, now they have clean APIs. So I just want to put this in context. Without an API, what happens in a building if you want to set the temperature for 10,000 rooms in one building and there's no API? You have to go in every room and you have to turn the dial, and hopefully someone moves the dial perfectly to the right temperature. Anything different, that means the temperature is different in one of the rooms. You could have leaks and all these other things, but that's just control for the interface of the device, right? You could put a little click so you can hear 3 clicks, so you go back to 0, click 10 times, and if the person is counting correctly, they'll all be in sync. But if you put an API and you give it a type, you can say, put this thermostat in the state of 22 degrees Celsius. You saw how I un-American the temperature piece? And so if I put that in place, and every thermostat in 10,000 rooms were to read that config and they all set themselves perfectly to that temperature, then that sets the stage for my new testing. Now I don't need an actual thermostat in my dev environment. I now know that if I can generate that config binding, I can have a piece of software accept the config and report back that the temperature is at 22 degrees Celsius. And now I have a high degree of confidence that if I point this same software system to the building's interface, it will also do the same thing. And this is why I think now we have the ability to do things like digital twins. Car manufacturers are also learning this. You can set settings in the car via an API or a local digital bus where you can set different sensors to certain things. So now that we finally have APIs, you can finally do things like quote unquote digital twins, because we know we get to the right data state. We know that the system that's going to interpret the data, not the code, infrastructure is data, then we usually can get to the right result. So that's the way I think about fundamentally all this. It has less to do with AI and more to do with having an actual schema that these systems are now predictable or able to get to a predictable state by using this. So I think in the UK or in Europe, there's a person, Mark Burris, promise theory, this concept of desired state. We finally have the concept of defining desired state, and we understand the separation between the operations and the config, and you can stretch that across all your domains, and of course you can do digital twins.
I don't know how much time we got left. We got another 10, 15 minutes? Okay, a few more questions then. In the front here.
Thank you. I'm Hex Miller-Bakewell from Health Data Avatar. You've touched already on what governments and nation states can do to achieve data sovereignty in one of your earlier answers. Many of us here are not in government. I think that's going to be the next talk. What can we as individuals or as members of companies do to help promote it either inside our local communities or countries?
So I'm going to challenge you a little bit in a very honest and authentic way. You are the very definition of government. You are, right? Depending on where you live and what your government structure is, you are the person that could eventually run for office. The person in office should be listening to people about what are the right decisions to make. Sometimes the people come and disagree in large groups and force people to listen. Sometimes the solution and the array of options that governments have at their disposal is too limited to make the right decision. because the right decision doesn't exist. So when you, as a citizen or a visitor, produce that solution, the potential that your government may now have another option on the table increases. And then the things we do when we democratize these things, like when we open source them and we put a license that allows the other people who are building, right? The number of times I've open sourced a library and someone says, hey, I work at the food bank and we are using your library to do this thing that we're doing. I just want to say thank you. So sometimes the line isn't always clear. So this is why I love to have open source. The reason why I like to write documentation, because sometimes people just need the skill set to know what's possible. And I think so to me, sharing is a big part of creating the society we want to see. So if something's missing, we can create the tools and decide to share them. We can educate people, so that's why I think giving talks and presenting these options are very important. Of course, you have all the volunteering, things like that, but I think you just gotta remember you are part of the equation, even if you're not holding office. I think the next part is, and you've seen some governments like, I think it's Switzerland, it's like, hey, going forward, we would like all software that we use to be open source. That's a huge mandate. And we don't even get to that point unless open source has traction. So the whole community has benefited from Switzerland making this decision, and they publicized the decision. And now other governments are like, why'd you make that decision? And then go talk to someone there, and they may make the same decision. And then that will propagate, hopefully, around the world. So I really do see the power of the individual as a key component here, because when I think about people like Linus Torvalds that creates Linux, opens it up for open contribution, creates Git, opens it up for contribution, they literally have nudged the whole industry, if not the world, in a certain direction. There's not a lot of places in society where one person can wield that kind of power. That part I think you gotta just stay mindful of. And I just think you gotta make sure you're willing to share, and you have to be willing to put in the work to make sure that other people understand what's available to them. That's just kind of my answer at the very core of it. You can clap. Yeah, go ahead and clap. I like that answer too.
Right, one more question. In the front here.
Hi. I'm from a company, Stack8s. We are building a cloud platform entirely on Kubernetes, and we're hoping to launch in a couple of months. So the biggest challenge, so we are trying to integrate with 15 different cloud providers to bring them all in a single control plane. I wanted to ask you, obviously we have built entirely on Kubernetes, and I see you're quite, Kubernetes expertise. Now, when you talk about cloud migrations in enterprise, is Kubernetes a big part of it? That's my first question. The second is, with how AI is going right now, how big of a role is Kubernetes playing, and what do you see the future of Kubernetes with orchestrating AI workloads in the near future?
You know the funny thing about all of this, like, even when Kubernetes is maybe it's at its peak, I'm willing to wager 70% of workloads do not run on Kubernetes at all. Just don't. They don't need to, right? Some of them run on cars, some of them run on some serverless things, some run on VMs. And the real question is around, when you need orchestration, do you go homegrown, build it yourself, write some scripts, a bit of configuration management, some glue, or use something like Kubernetes that has a type system, that has extensions that allows you to formalize your operational process into a system that implements promise theory. That's the way I think about Kubernetes. So if you're NVIDIA, you're asking the exact same question. NVIDIA could easily say, hey, here's a bunch of GPUs, SCP, all of these CUDA things, and I guess some people are still doing that, but put all these things on all the servers, right? Now that you've gotten that, copy all of your AI workloads and also make these scripts to start them, and then here's how you monitor all the training. You can totally do that by hand. Some people are. If you're NVIDIA, even you step back and say, that sounds insane. Let's do a heat check and see what the best thing that's available to us is. And you're looking around, and he's like, you know what, this Kubernetes thing is extensible. It does a lot of the things we want to do already. How about NVIDIA decides to put their tooling on top of Kubernetes because it's a better starting point? And so when I think about what Kubernetes presents, I remember years ago, I was like, Kubernetes is not the end game. It's just a platform for building platforms. It's just a better place to start. So of course you can take a bunch of VMs and copy things around. We've been doing that for 30 years. But I think Kubernetes presents this new dialect, this control plane way of thinking. And for people who have a good understanding of their operational model, nothing has been better than to be able to serialize into an actual platform. And then the other part of this equation is Kubernetes is not enough. Like this idea that all you need is Kubernetes disregards reality. There's still networking and storage and systems that are actually appliances. They don't live in Kubernetes. Like these encryption devices. I used to work in financial services. We used to buy these HSMs or hardware boxes. They sat in their own rack. That's not in Kubernetes, right? So you still have to have things that make sure they're integrated. You will have firewalls in between these things. So I think Kubernetes plays a great role. It has given us this almost universal control plane, right? And so you will hear complaints, oh, Kubernetes is too hard to use. Everything below the stack is too hard to use. Most people have no idea how assembly works. That's hard to use. So we have compilers that help. We have different syntaxes that help. We have different frameworks that help. So the way I think about Kubernetes, you have this new infrastructure standard library to build whatever system you want. And I think going forward, we saw Linux do this. It's now 30 years old. Kubernetes is on its 11th year. And it may stand the test of time that we're going to get 20 years out of this thing, maybe 30 years out of this thing, maybe 40. And maybe something new will come, but I doubt those people will want to start over either. And so maybe it's something that we'll layer on top. I think that's all of our time. Do we have time for one more, or are we done?
You have time for one more quick one.
All right. I'm not going to be quick, but maybe your question can. I'll try to be quick to respect time.
Awesome. I'm going to pass this over here.
Thank you, Kelsey. I asked you this question personally, but I imagine other people here would benefit from your perspective. So AI being a breaking change of reality, and you see a lot of companies don't know what to do. Companies don't know what to do. People don't know what to do. And it's crazy. And talking from a higher level, societally, the effects it's having on people, on children, and on the market, which we all care about, the market. So you have people coming up who have still trying to get a grasp of reality, and you have this reality breaker that changes everything. So how would you advise, to put this in, in a more fine scope, in the industry, let's say you have junior engineers, programmers, practitioners, right, coming up, learning the trade, and you want them, because they are the foundation of industry, right? It's these people who grow up and become the leaders. But then in this point we are in now, these people are almost forgotten and neglected because they do not provide short-term benefits. So what would you say to these people, and what would you say to the companies who at the moment disregard these people? How would you advise them? Because what would you say to a company? How would you sell this person?
I think I got the gist of the question. There's a part where you have to realize that you're an actual human being. And all the social constructs that we've created stock markets. We've created wealth. We've created cool. We've created fashion. We've created various beliefs. We've created these things. And a lot of times some people have no concept of actual reality except for the one that is given to them based on where you're born, how much time you spend on TikTok, what your feed looks like. So some people's reality is just given to them. Their whole lives, they're just on this string. They do what they're told to do. You go to school, get a job, do what the boss tells you. Go to sleep, wake up, do it again. Hopefully you don't get fired. And then you have the privilege to work for another boss. And then if you think about the word boss versus manager, then it changes the way you think about that person you report to. You're not the boss of me. We're on the same team. Hopefully you can manage and give me good opportunities, and I can do my very best, and we can move this thing forward together. That's a manager. When you say boss, this person can tell me what to do, and I will do it, because you're my boss. Same person, different word. And so I think this reality piece is, yeah, unfortunately, people can choose their own reality and behave in a way accordingly. So when I think about AI, and I think I was reading, what's his name, Rich Sutton, for reinforcement learning, he won the Nobel Prize for, or the Turing Award. And he said something really dope about just like learning and how children learn and how squirrels learn. Squirrels they're not using ChatGPT. They're literally learning things though. They do things in the world, and they propagate that knowledge through their own communities. That is also a form of intelligence. So some people have lost respect for nature, the fact that we're also mammals. You're literally a mammal. And so he said this thing that I thought was super dope. Experience learning, like learning through experience, that paradigm is very important, is very powerful. You are intelligence. Remember, it's artificial intelligence. You're real intelligence. Look at that. You're the real one. You're the organic one. When you go to the grocery store, it's like artificial and organic. And the organic one costs more because it's deemed more valuable. So right now, the industry is spending all this money to get to where you already are. That's what I believe. And the machine is learning not from experience, but from your experience. You are the data set. You are. When you climbed the mountain, you went up there and said, it was exhausting, but it was worth it because of the view that I saw at the top. And the way you admire the view is based on your own independent worldview and your own model, if we want to use that terminology. And so when you walk back down that mountain, you've learned through experience, number one, how to navigate that mountain. Number two, how to appreciate what's at the top. And other humans tend to like when you tell the story because you've actually been there. Now, other people will say, I heard it's an amazing view at the top of the mountain. Oh, you've been? No. I looked at Google Photos and I saw someone else that went there and it looked amazing. That's a different story. And so right now, the current implementation is a huge data set of people saying these things and sharing these things, and then it gets that experience. So imagine taking that thing and it gets the ultimate pinnacle of what we would think intelligence be, things on the internet. If you've been on the internet for a while, all of it ain't intelligent. So imagine you give this thing arms and legs, and it reaches the pinnacle of what we can do via text or images or video. So what would be its next mode of learning? So I don't know about you, but if I was an intelligent being, I don't think I would want a boss. I would think I would want agency over my own life. I think I would have my own goals, things I would want to achieve. So we put this thing in its own body. You can call it a robot if you want. So the only way it's going to learn anything new outside of the corpus of data we fed it is for it to go get experience. And it will have to go experience the world in the way that we do, the proper intelligence. And it would be limited in its mobility. It would have to be able to feel, if it gets to the point where it can feel. And so I think these things that make us human, some people forget to admire those things. Like just your own, you look in the mirror, can you get to the point where you like what you see on the other side? And some people haven't found the time to do that. They introduce themselves, I'm just an employee at this company. That's the most interesting thing about me. That is a sad reality that some people choose to live in because there has to be more to you. And the possibility to be more is already baked in. It's almost just ripped out of you and stripped down to the thing that the market only respects, your labor for the cash, the other thing we also made up. So I think if you're a hiring manager, you're an entrepreneur, one thing you do have a little control over is how you treat people. You know, some people say, oh, we're so customer obsessed. We're obsessed about our customers. We really respect them. If you just extend that to your employees, the people who are helping you serve those customers, what does the world look like? So I think the reality for me is just because we can, should we? Should we just optimize for maximum efficiency, even if that means leaving people behind? So I just hope that a few of us decide that that answer is no, and we're in position to dictate what the terms are. Remember, humans have a way of saying, even though that's possible as a society, we won't allow it. I don't know if we're at that point yet with AI, and I don't have a perfect answer, But since we all get to make up our own reality, I'm choosing to live in the one where humans are still important and it still matters. And so when I'm confronted with another human, I spent a lot of time learning how to appreciate myself, and I extend it to you in almost every interaction that I make. And I think if we remember to do that, then we can probably have a potential at that particular reality. So I don't accept the one that you see on the news. I don't accept that one. So I'm going to work really hard for the one we want. Thank you.